Okay, so we have spent some time looking at perpendicular bisectors, and we've also looked at some other segments, but for right now, for today, we're going to focus on the perpendicular bisector. Some of this first part will be a review, but that's okay. So we want to know, what is a perpendicular bisector? And as we had taken some notes on this before, we know that in order to have a perpendicular bisector, you first start with a segment, okay? And then you are going to find the midpoint of that segment. So this is going to be right in the middle. And then the perpendicular bisector goes through that red point at a right angle. Okay, so that's what a perpendicular bisector actually looks like. Okay, and so then what we know, oopsie, didn't mean to do that. Then what we need to think about is, if I put a point on that perpendicular bisector, if point C is on the perpendicular bisector, then it is the same distance from certain things. So if this is point C, okay, so we'll put point C right here. And we want to think about what that would be the same distance from. Well, point C is going to be the same distance from the endpoints. So let's call this A and B for our endpoints. So if we measured from C to B and we measured from A to C, those would be the same length. So these two would be congruent. So if point C is on the perpendicular bisector, then it is the same distance from the endpoints of the segment. Okay, so for example, in this picture here, we could say that AC equals CB. Okay, so let's use that idea. We're going to use it a couple of different ways. We want to find RS. So we want to find what the length of this segment is. Okay, so first of all, is SQ, that line going down the middle, is it the perpendicular bisector of RP? Well, if we look at what's marked there, we notice that it is perpendicular, and we notice that it goes through the midpoint. So yes, it is the perpendicular bisector. So if it is the perpendicular bisector, then it is the same distance from both endpoints, which means if this is 6.8, this is also going to be 6.8. Pretty simple, right? We haven't even put any algebra in there yet. Okay, kind of working the other way with it, right? So we don't know that this is the perpendicular bisector, but we do know that this and this side are the same length. So it kind of goes backwards from what the previous slide was, where we said if it's the perpendicular bisector, then those two sides are the same. Well, if those two sides are the same, then it's the perpendicular bisector. Well, we know it's perpendicular, which means if this is 9.5, we know that this also has to be 9.5. Okay, let's make it a little bit more difficult, right? So we look, BD is the perpendicular bisector, which means if BD is the perpendicular bisector, then the two lengths from D to the endpoints of the segment are going to be equal to each other. So to find x, we would just say that 3x plus 14 equals 5x. If we subtract 3x from both sides, we get 14 equals 2x, and x equals 7. Okay, so then it wants to know, well, what is the length of those segments? Well, AD, that's over here. I'm going to have 5 times 7, which is 35. And if we did it correctly, right, CD should be the same thing, but let's just double check. If we did 3 times 7 plus 14, 21 plus 14 is in fact 35. And they should be the same length, because since it falls on the perpendicular bisector, those two lengths should be the same. Okay, so now we're going to get into what we talked a little bit with the GeoGebra activity that we did, where if you actually make perpendicular bisectors of all three sides, you find that they all meet at this single point. And that point is called a point of concurrency, where they all three meet, and it is called the circumcenter. Okay, and what do we know about the circumcenter? Well, what we did the other day with our GeoGebra activity is we found the distance from our circumcenter to each of our corners of our triangle. And GeoGebra went ahead and measured those for you, and you should have found that the circumcenter is the same distance, equidistant, to the vertices or the corners of the triangle. Okay, so let's kind of put that into practice just a little bit here. Okay, so one other thing that you also should have learned from the GeoGebra activity that we did is just some vocabulary and some things we should have known. The circumcenter is the point of concurrency we just talked about for the perpendicular bisector. So circumcenter and perpendicular bisector go together. They meet, the perpendicular bisectors meet at the circumcenter. The circumcenter, like we said on the previous slide, is equidistant to the vertices or corners of the triangle. We're just repeating what we just did. Okay, then as you did those, you screenshotted in GeoGebra, you screenshotted different triangles. In an acute triangle, the circumcenter was inside the triangle. If you had a right triangle, the circumcenter was on, specifically on the midpoint of the hypotenuse. And these are all things through the GeoGebra activity that you did that you should have already discovered, okay? And then in an obtuse triangle, that circumcenter moved to the outside of the triangle. Okay, so let's take a couple looks here at what that might look like, okay? It says P is the circumcenter, okay? So P is the circumcenter, and we just said on the previous slide, well, this is an acute triangle, so P is on the inside of the triangle. And we said that point P is the same distance from all three of the corners of the triangle. So all three of these red lines are going to be the same length, okay? So if it tells me that PB, right here, says PB equals 3x plus 2, so PB, that's this one right here, is 3x plus 2. And PA, that's this guy right here, is 4x minus 8. We can easily find PC, right? Because they all three have to be the same. But in order to find what PC is, I need to figure out what one of the other two is. And to do that, I know they're the same length, so I know that these two are going to be equal to each other. So I know 4x minus 8 is going to equal 3x plus 2. And if we solve that, if I subtract 3x from both sides, I get x minus 8 equals 2. And then if I add 8 to both sides, I get x equals 10. Notice none of the side lengths are 10. That's what x is. So if we wanted to figure out any of these side lengths, we could just put 10 back in. So I'd say 3 times 10 plus 2 is 32. Well, if PB is 32, by golly, PA over here, it better also be 32, but let's check it. So we're going to say 4 times 10 minus 8 is 40 minus 8, which is 32. So that is correct. And if these two are both 32, then PC is also going to be 32. Okay, our last example that we're going to look at here has more information on it, okay? So it says point P is the circumcenter, and we said P is the same distance to the corners of the triangle. So we know that this red line right here, this red line right here, and this red line right here are all going to be equal or the same length. This 32 that is out here is just there to try to confuse us. We want to focus in on what we know about circumcenters, which is that the circumcenter is the same distance to the corners. So if we go from P to any of the corners, it's all going to be the same. So I know that PB, which is 6x minus 28, is going to be the same length as PA, which is 38. Okay, it's also going to be the same length as PC, but we'll get to that in just a second. If I want to find what x is first, I add 28 to both sides, and I get 6x equals 64? No, 66, sorry. 66, which means x equals 11. So then we go back and we say, well, what are the lengths of each of these segments from the circumcenter to the corner? So we have x is 11, so we'd say 6 times 11 minus 28. Okay, 6 times 11 is 66, minus 28 is going to be 66 minus 28, which is going to be 38. Okay, and 38, which also means that PC, this length here, is also going to be 38. The key with the pictures to make sure, focus in on what you need to be looking at, because there's sometimes extra lines in there and there are sometimes extra information. So make sure you're paying attention to just the information that you need, and you can cross out any other stuff that might be extra just there to confuse you. When you finish the notes, there is a class kick that you can work on. So good luck, and let me know if you have any questions.